Okay, so today we're going to focus on segment relationships. And remember that the segments are chords, and chords can be formed a number of ways, but chords can be formed by secants. A secant line, remember, crosses through the circle and intersects at 2 points, so that forms a chord. And then we're also, well, it's not just a segment, we're going to talk about tangent lines. There's some properties that we can use. And so let's just jump right in. So if I have this perfectly drawn circle, and I have the chord A, B, and then I have another chord C, D, and then this is not necessarily the center of the circle, although it kind of looks like it, but it's just the intersection of the two chords. The one thing I know about the segments, the chords, segments of chords theorem, the relationship A to E times E to B should equal E to C times E to D. Okay? So E to A times E to B should equal E to C times E to D. So let's plug some numbers in and do example number 1 and try to make sense of this. So if I say example number 1, I'm going to have a perfectly drawn circle. I have a chord like this and a chord like this. Now there's been some properties. Well, let me just write out, let me label this. So this is J, this is K, this is M, this is L, and then this little point right here is N. And then we're told that this line segment here is x minus 2. This line segment here is x minus, oh, it's x plus 2, x plus 4, and x plus 1. Okay? And so what we're told is that this property applies. Okay? And then we're told this is x. So if I look at my formula, this is how you do your homework, this is why we take notes. I need to know what I multiply by what, how to solve for x. Okay? So if I look at this formula, I go from where they intersect out to this edge times the intersection point to this edge. So this AB chord, I'm going to take this segment of the chord and multiply it by this segment of the chord. And then EC times ED, I'm going to take this segment of the chord CD and multiply it times the other segment of the chord CD. So I'm going to do the same thing here. I'm going to take this segment, X, right? And I'm going to multiply it by X plus 4. In other words, I'm going to say K N times NJ is equal to MN times NL. Okay? And then, so over here, because I'm going to start to run out of room in a second, then I've got x plus 2 times the quantity x plus 1. So now this is easy. I'm going to push the x through. X times x is x squared, right? Then x times 4 is positive 4x. Now this one I'm gonna do the work over here. I'm going to draw my little box. And I'm going to say x plus 2 times x plus 1. X times x is x squared. X times 2 is 2x. X times 1 is 1x. And then 1 times 2 is a positive 2. So this becomes x squared, that's this term here. Then I take my like terms, 1x plus 2x equals 3x plus 2. Now I got to solve for x, so I got to get all the x's over to the other side. Oh, this is x squared. Right? X times x is x squared. I said it, but I didn't write it down. So the first thing I'm going to do is I'm going to subtract x squared from both sides. And essentially those cancel, and I get 4x is equal to 3x plus 2. I'm going to subtract 3x from both sides. And then I'm going to get 4 minus 3 is 1. X is the same as x, and then that leaves me with 2. So I get x equals 2. Now, if I was originally told find the length ML and find the length JK. Well, ML is x plus 2, right? That's this segment here, plus x plus 1. But x is equal to 2, so it's like 2 plus 2 and 2 plus 1. So 2 plus 2 is 4, plus 2 plus 1 is 3, so the whole thing is equal to 7. JK is just going to be j to n plus n to k. So jk equals jn, which is going to be x plus 4 plus x, or 2 plus 4 plus 2, which is 8.